This is Pluto, a familiar sight these days thanks to NASA's New Horizons spacecraft, which flew by in July 2015. This mission gave us the first detailed look at this icy world, revealing its breathtaking landscapes. We saw frozen nitrogen cliffs, giant ice shards floating like icebergs, cracks deeper than the Grand Canyon, and its famous heart-shaped feature. Despite these incredible high-definition images, a significant portion of Pluto remains shrouded in mystery, the far side, the hemisphere opposite the one we're familiar with. So, what does the other side of Pluto look like? You're watching Space Explained. If you enjoy our videos, remember to subscribe for much more to come. When Clyde Tombaugh discovered Pluto over 94 years ago, it was just a tiny speck of light, barely visible even through the largest ground-based telescopes. It wasn't until 1996 that the Hubble Space Telescope provided the first surface details of Pluto, though they were fuzzy. These images hinted at a world with more large-scale contrast than any other in the solar system except Earth. Then, in 2015, after a 9-year, 5-month journey, NASA's New Horizons spacecraft arrived at Pluto and discovered a world far more dynamic than anyone had imagined. Unlike many planetary missions, New Horizons did not enter into orbit around Pluto due to budget constraints, time, and the high speed it was traveling, over 84,000 kilometers per hour. Instead, it performed a flyby with its closest encounter lasting only a few hours. We only observed one hemisphere of Pluto in high resolution because the dwarf planet rotates every 6.4 Earth days. As New Horizons flew by, one side was illuminated by the sun while the other remained in darkness. This stunning image taken by New Horizons after it passed by shows the illuminated side. Using images taken from up to 6 million kilometers away during its approach, scientists revealed Pluto's hidden hemisphere. So, what stunning features was this bizarre world hiding? Even though the spacecraft was millions of kilometers away when it captured the far side of Pluto, the resolution of these images is still 100 times better than what the Hubble Space Telescope has provided of the same region. We can just about make out some prominent features. In some ways, both sides of Pluto are similar. For example, steep ridges called blades can be seen on both hemispheres, stretching up to a kilometer high like skyscrapers above the surface. Scientists think this bizarre bladed terrain forms similarly to penitente features on Earth, where snow or ice sublimates, turning directly from a solid to a gas without becoming liquid first. However, penitentes on Earth are much smaller, only reaching about 5 meters high. The most intriguing features on Pluto's far side that aren't found on its near side are thick, long, dark lines crisscrossing each other. They are on the direct opposite side of Pluto's heart, something scientists think resulted from the same event that formed Pluto's heart. Called Sputnik Planitia, this western lobe of Pluto's heart is thought to be the scar of a cataclysmic impact event. One popular theory suggests that an object over 640 kilometers wide collided with Pluto, creating a giant basin that eventually filled with slushy water from an underground ocean welling up into the chasm. Afterwards, nitrogen gas in Pluto's atmosphere condensed and froze over the frigid basin, creating the bright white scar we saw when New Horizons flew by. These dark lines on Pluto's far side support the idea of a giant impact because they might result from seismic waves that raced around the dwarf planet, creating a chaotic terrain of ridges, cracks, and plains on the opposite side. This phenomenon isn't unique to Pluto. Mars and Jupiter's moon Europa also show evidence of collisions with scars from seismic waves racing through and around their terrains. Surrounding this chaotic terrain, another geological oddity can be seen: enormous cracks and fault lines stretching from Pluto's north pole to its south pole. These fractures may be caused by the gradual freezing and expansion of a subsurface ocean. As this internal ocean slowly solidifies, it increases in volume, creating immense pressure that fractures Pluto's icy crust. Just as Pluto's heart suggests a hidden ocean, so do these cracks, indicating that even in the cold depths of the Kuiper Belt, seemingly frozen worlds like Pluto can harbor hidden oceans, raising the intriguing possibility of subsurface environments capable of supporting life. These incredible far-side images also revealed that the striking dark regions on Pluto's illuminated side form a band that wraps around the entire dwarf planet, interrupted only by the heart feature. Called the Cthulhu Regio, this dark band contrasts sharply with the brighter icy regions and is thought to be composed of tholins, complex organic molecules formed by interactions between ultraviolet light and cosmic rays with methane and nitrogen. Unfortunately, with these images being as fuzzy as they are, it's unclear how much more we'll learn about Pluto's far side. Larger telescopes planned on Earth may help, but there's no substitute for being there and capturing close-up images. It's unlikely we'll see another probe visit Pluto for many decades, as our solar system is full of other planets and moons yet to be explored up close. For instance, we last visited Uranus and Neptune in the late 1980s, so these blurry images are the best we have to complete the map of Pluto. However, they show that this icy world still holds many fascinating secrets. I hope you enjoyed this video. Pluto is an incredible world, but the universe is full of many other fascinating locations. Why not click on one of these videos next? Thank you for watching, and I'll see you next time.